Today we're going to talk about angles and triangles. A couple reminders before we get started, and you can feel free to just add this information at the top of the organizer that you have. First of all, when we're talking about triangles, we need to remember that inside each triangle is 180 degrees worth of measurement. Also, when we're talking about triangles, we need to remember that we have three key types of triangle. Equilateral triangles, we'll remember, have obviously our three sides, but each of those sides is congruent or the same side, and each angle in every corner is going to be exactly the same. Isosceles triangles, we have one side that is a specific length and two sides that are congruent. When we have isosceles triangles, we also have two angles that are the same and one angle that is different. So angle the same, angles that are different, and we'll come back to this in a little bit. Lastly, when we're dealing with scalene triangles, what we're dealing with are triangles that have three different side lengths and three different angle measurements. So if we have a scalene triangle, we might have side lengths that look like so, and each angle is also going to be a different measurement. When talking about angles, it is important that we remember that we have some different ways that we can measure our angles. If I'm dealing with a right angle, remember what I get is two lines that are perpendicular, and those lines are going to make my right angle and have a measurement of 90 degrees. If I have an acute angle, I have something that is between 1 and 89 degrees. An obtuse angle might look something like so and measures between 91 and 179 degrees. And if I have a reflex angle, what I have is something that measures 181 to 359 degrees. Now, working from the organizer that you have, we're going to take a look at what our angle measurements can be. And I would encourage you to, like I'm doing, write right on your organizer to help keep your angle measurements clear. We can see that we have three angles in our triangle, obviously, angle A, B, and C. And one thing that you might be asking is why are these listed a little bit differently than when we're actually measuring things like complementary angles or supplementary angles? Remember, because we have a closed or an enclosed shape, we can just list off the corner that we're talking about or the angle that we are talking about. So what we are given is information that angle B is equal to 41 degrees. So we can write that right on our page to help us keep track. Now obviously, at first glance, we have two missing angles, or two angles that we do not quite yet know, but we do actually know that angle A, because we can see our little marking here, is going to have a measurement of 90 degrees. So this is actually indicated that we have a right angle. So for angle A, we can write in 90 degrees. Now in order to figure out the measurement for angle C, again, we know that in our triangles we have 180 degrees total. So if we take our 180 degrees and we subtract the 41 from angle B and the 90 from angle A, what we're going to be left with for a measurement at angle C is a measurement of 49 degrees. So when we were looking down here for angle C, we've calculated a measurement of 49 degrees. Moving down our page, if we take a look at this particular triangle here, what we can see is some unique markings. And hopefully, even though it may not be drawn this way, we have to go by what the markings tell us. We're noticing that we have tick mark, tick mark, tick mark. So this is indicating that all these side lengths are exactly the same. Therefore, all of our angles actually have to be exactly the same. So just for clarification, we can draw in that angle P, angle Q, and angle R are all going to be equal or congruent. Now, again, we know that we have 180 degrees inside our angle, and we know that that is split up evenly between our three corners or our three angles, which is telling us, simple math, that each angle or angles in our equilateral triangle are each going to have a measurement of 60 degrees. So down our side where we're keeping track, for each one we can write 60, 60, and 60. Really straightforward. When working with our third type of triangle, what we have to again look for are some geometric markings that are going to help us identify the type of triangle and therefore the type of angles that we have in each triangle. Here we can see that we have one marking, one marking. So what that is telling us is that those two sidelines are congruent or the same. What we have down here is two markings, which is telling us that even though it may not appear that way, that line is actually a separate length. So we do have 65 degrees that has been identified for us. But now we have to figure out and determine which other angle is going to be equal to 65 degrees. We know that in this type of triangle, in an isosceles triangle, that we do have two measurements that actually are the same measurement and one that is different, just like we have two lines that are the same measurement and one line that is different. So the way that we are going to think about this is where we have our two congruent lines, right? We can see that those lines meet at angle or corner Z or Z. This is telling us that this is the common corner and it is shared between these two line segments. And what I mean by that is, if we take a look at this line here, we could call this line XZ or XZ. If we take a look at this line here, we could call this line YZ or YZ. So because this is the shared point, all right, or the common point, that's going to help us know that that is different. So again, our common point or angle is different. So if I know that angle Z is different, what that is telling me is that angle Y has to be the same as angle X. And in order to calculate the measurement for angle Z or Z, I can just add my two known angles together. That's going to give me a total of 130 degrees. And then to figure out the measurement for angle Z, I can take the 180 degrees in my triangle, subtract by the 130 degrees that are already used up or taken up, and that's going to be a remaining measurement of 50 degrees. Take a moment and figure out the questions on the bottom of your page on your own. All right, just to double check what you've practiced on your own, in example A, what we have is a triangle that has three different side lengths. We can see side length 1, side length 2, side length 3. Therefore, we know that it has to have three different angle measurements. Two of our angle measurements are given to us, so all we're looking for is the measurement for angle C. So again, we can take our 180 degrees total, subtract the measurement of angle A, which is 65, subtract also the measurement of angle B, which is 80, and our remaining measurement for angle C is going to be 35 degrees. When we take a look at example B, what we have is, again, some geometric markings. And even though we don't have every single side marked, we can notice that marking here, that is telling us that those two lines are the same length or are congruent. So where those two lines meet or come together, or whatever that common corner is, in this case it's going to be point P. This one is going to be our different angle. So that's telling us that we already know that point R or corner R is going to have a measurement of 70 degrees. If this is the different one, we know that point Q or angle Q is also going to have a measurement of 70 degrees. So to determine the measurement for point P or a different angle, we can just take again our 180 minus 70 minus 70, which is going to leave us with a remaining measurement of 40 degrees.